charge on electron. How charge can be established? Millikan has given a experiment. R.A. Millikan devised a method known as oil drop experiment. He has dropped the oil droplets, he has put it in a container, and which container which is associated with different kind of plates, positive and negatively charged plates was there, and it is observed by the telescope and the X-ray detection. It is observed when the particles fall what kind of behavior it is showing. So to determine the charge on the electron, now the charge on the electron to be 1.6 into 10 power minus 19 coulomb. Okay, the mass of the electron was determined by combining these result in Thomson value of E by M ratio. In E by M ratio, if we take the charge on the electron 1.6 into 10 power minus 19 coulomb, what we are getting it? Just we can see the mass of the electron we are getting it, that is 9.1092 into 10 power minus 31 kg. Okay, this will be the mass of the electron. Okay. Now in this oil drop experiment also we will discuss here this kind of experiment. Here oil droplets will be dropped and there are two charge plates. X-ray observation is there, telescope is there which can observe the points how the oil droplets are dropping, and atomizer will be taken to spray the oil inside the container. And then what happens when the oil droplets falls through X-ray and telescope which is observed, the charge on droplet, it depends on polarity and strength of voltage applied on the plate. Okay, so like that the charge of the particles can be determined by oil droplet method. Here this is the oil droplet method given by R.A. Millikan. So discovery of proton and neutron we are talking today. Electrical discharge carried out in the modified cathode ray tube led to the discovery of particles called positive charge, also known as canal rays. We have discussed in the previous class about cathode ray tube, that was the cylindrical glass tube, and both the side there was electrode, and when the electric discharge is passed, the vacuum was created inside and the particular gas was present, and when the electrical discharge, the particle gets charged, and because of the charged particle will start moving. So we had observed in case of electron in cathode ray tube, the particles was getting attracted or getting flowing towards the positive plate. So that was indicating the charged particles was negatively charged. So electrons was negatively charged. Like that few points have been established about electron. Now here canal ray tube we are talking. So the characteristics of these positively charged particles are, unlike cathode rays, positively charged particles depends upon the nature of gas present in cathode ray. We have already discussed in discovery of electron that gas inside was present was not depending on the mass and the charge present on that particular gas which was inside. So that was electron in case of electron. But here in positively charged particles, particles depends upon the nature of gas present in the cathode ray. Okay, so the charge to mass ratio of the particle is found to be depend on the gas from which it originates, mass to charge ratio. Okay, so slowly we will come to that also. I will tell you just about that, like mass of a particular atom is decided by proton and neutron which is present in the nucleus. Electrons are very lightweight particle, that is why the whatever gas was filled in cathode ray tube in the discovery of electron was not playing any role there. Mass and charge ratio was very small. Here the mass plays a role because the mass of the atom is decided by these particles. So the mass ratio of the particle is found to be depend on the gas, which gas is present there and the origination. So mass charge ratio of the gas which is filled in the canal ray is also playing a role here. Next we are talking about some of the positively charged particles carry a multiple of gas from which they originate. Okay, so what kind of gas is present and what kind of charged particles are originated from that. The behavior of these particles in the magnetic and electric field is opposite to that observed for the electron and cathode rays. Okay, so electron behavior in magnetic and electric field was totally different. We have done one experiment where the charged particles was getting, if only electric field is applied, charged particles were attracted. There were 3 points A, B and C. So the charged particle was attracted towards the point A, and then when only magnetic field is there, that time the charged particles was getting attracted to C, and when both the fields are not there, that time the particles was towards the B in the straight line like that. So we were discussed already in case of electron this. Now here what is the difference from that particles to this? The behavior of these particles in what are the fields we are talking? Magnetic field and electrical field is opposite to that of as observed for electron. Okay, the smallest lightest positive ion was obtained from hydrogen and was called proton. Hydrogen, all of us know hydrogen is the number one element in the periodic table and which has a smallest atomic mass, atomic number, correct? So that was positive ion was also obtained from the hydrogen gas for experimental purpose, and that was only called a proton. Okay, that's what when the hydrogen ions we are talking like H3O plus ions are there, they are called protonium ions, because hydrogen H plus ion is taken as a proton. Okay, and the ions will be taken, H3O plus ion will be taken as protonium ion. Now later a need was felt that the presence of electrically neutral particles are also required, like we had positively charged particle protons, negatively charged particles electrons, and now that neutral particles, now there is no charge present, neutral particles are also required. Presence of electrically neutral we are saying as one of the constituent of atoms. These particles discovered by James Chadwick. Okay, what was the name of a scientist? James Chadwick. James Chadwick has discovered about neutron. How he has discovered? When electrically neutral particles having a mass slightly greater than that of proton was emitted, named as neutron. Okay, so the particles which was emitted and which has a mass slightly greater than the proton was emitted. There was no charge present, but the mass was more than the proton. That particles are called neutrons here. Okay, so